Now we are ready to take a look at rational functions. So let's start with rational functions and their graphs. So first of all, a rational function is any polynomial divided by another polynomial. Remember, something as simple as like 5 can be a polynomial. That's a degree 0 polynomial, just the number 5. Okay, so this is a very wide definition. So for example, 1 is a degree 0 polynomial divided by x, a degree 1 polynomial. That's an example of a rational function. X plus 1 over 2x squared plus 5x minus 3 is an example of another rational function. The simplest rational function is 1 over x. Now let's look at what happens as we get near 0 on the x values. Near 0, I would be plugging in very small numbers like 0.1, 0.01, 0.001, and I see that these y's get bigger negative values when the x is negative and bigger positive values when the x is positive. That is, as x approaches 0 from the left through negative numbers, right? If I'm looking at a graph here, and here's 0 right here, these are my negative numbers I'm approaching from the left. The y values approach negative infinity, so my y's go down. As we approach 0 from the right through the positive numbers, so I'm approaching this direction from the right, the y values get extremely large positive values, so we're going up on the graph. Now the other thing that we can do is plug in really large x values, and what happens is the y becomes really, really small, positive when it's positive and negative when it's negative. If I'm becoming small, these numbers are becoming closer and closer to 0. So as x approaches infinity, as x gets bigger, as x approaches infinity, y approaches 0 through the positive values. As x approaches negative infinity, now again on my graph, approaching positive infinity is going this direction, that's this, so our graph's going up. I'm sorry, our graph's going towards 0 because we're getting back 0 values. And approaching negative infinity is this direction. Again, our graph is going towards 0, but again through negative values going that way. Okay. All right, so this tells us, now by the way, I can't plug in 0 because 1 divided by 0 is undefined. So my domain is all numbers except 0. My range is all numbers except 0. As we approach positive infinity, it gets too close to 0. As we approach negative infinity, it gets close to 0. As I approach 0 from the right, it's getting to really big positive values. As I approach 0 from the left, really big negative values. Let's use that to graph negative 1 over x plus 4. Now, remember from our discussion of transformation, this flips the graph upside down, right? Flips it over the x-axis because that negative's on the outside of the function. And this would shift up 4. Now I'm starting with this basic graph for 1 over x. So if I flip it upside down, this arm's going to be down here and this arm's going to be up here. So my graph of negative 1 over x will have this arm going like this and this arm going like this, right? Just the upside down of what we saw in the previous slide. Now, the up 4 shifts it up 4. So now let's actually draw it. Since I'm going up 4, this, where we didn't touch anything, which by the way is called a horizontal asymptote, moves up 4 units. 1, 2, 3, 4. So I'm going to have a little dotted line here, and that's like the new x-axis. Now I didn't move left to right, so the y-axis stays the y-axis. But this has been shifted up 4, so it's going up like that now, and this was shifted down 4 like this. So it looks like this. Now if I want to find this exact intercept point, I would set this equal to 0. So I would go 0 equals negative 1 over x plus 4. Add the 1 over x to the other side. Cross multiply. And then divide by 4. So this is at the x value of 1, 4. All right, let's graph this one. Now let's look at what's happened here. This minus 4, see, this one was outside the function, so it's a vertical shift. This one's inside the function, so this is a horizontal shift. So this is going to take me right 4, stretch 3, down 2, because that minus 2 is outside the function. All right. Oh, I'm sorry, and I'll go back and give the domain and range on the previous one in a second, because I did forget to do that. So let's take a look at our graph. So starting with the y equals 1 over x, if I shift right 4, 1, 2, 3, 4, that now places that vertical asymptote that was the y-axis over to the right 4 units. The down 2, 1, 2, shifts me down 2 units. Now it's easier to apply the stretch to the original function because we know things like it passes through the point, the original function would pass through the point -1, -1. So if I multiply by 3, it would pass through the point -1, -3, because I stretched it. So we're just multiplying the y. Well, if I've moved it right 4, that would now be +3, -3, down to +3, -5. So 1, 2, 3, 4, 5. Got a point right there. Okay? And so on. So the same thing we would shift all the points on the graph to show that stretch by 3. So if I'm looking at the point 1, 1, right there on the original graph, the point 1, 1 would be moved, would be stretched by 3, so it would be the point 1, 3, right 4 would take it to 5, 3, down 2 would take it to 5, 1. So here at 5, we have a point at 1. And that allows me to show that stretch, otherwise the graph looks the same. Now what happened to the domain and the range here? Well, our domain, we shifted to the right, so we weren't allowed to have 0, now it's over here at 4. So this is -infinity to 4, union 4 to infinity. And our range, we weren't allowed to have 0, but we shifted down 2. Well, so now instead of going -infinity to 0, it's going to go -infinity to -2, union -2 to infinity. Let's look at the previous example because we forgot to do that there. Our domain, we didn't shift left to right, so it didn't change the domain. So the domain was all but 0, just like before. Now the range, our range is -infinity up to 4, and then again from 4 to infinity. All right, now we want to do exactly the same thing we did in the last example, but this time we want to do it on this function. What's different here is that I see an x in the top and in the numerator and the denominator. So I'm going to use division to simplify that. So we're going to say x plus 1 divides into x minus 3. We can go in once, x plus 1, subtract, we get a -4. So that means that this function can be rewritten as 1 minus 4 over x plus 1. Now we see this is left 1 unit, flip, and then this is being added outside, so up 1. All right, so if we do that, now we have the 0, 0. If I go left 1, it's now over here at -1. So I'm going to draw my vertical asymptote through that. Now the flip, oh, and by the way, this is the stretch. So the flip, this arm's going to be down and this arm's going to be up, right? The opposite of what we saw on the original graph. Stretched by 4, so the point 1, 1 would now be the point 1, 4, but it's moved to the left by 1. So that would be the point 0, 4. And then we're going to move it up 1. So we need our horizontal asymptote at 1. Okay, So that point that was positive 1, 1 is now positive 1, negative 4. Then this shift would take it to 0, negative 4. And then the up 1 would take it to 0, negative 3. 1, 2, 3. Right there. Now the point that was negative 1, negative 1, this minus 4 would take it to negative 1, positive 4. This would take it to negative 2, positive 4. And then up 1 would take it to negative 2, positive 5. 1, 2, 3, 4, 5. All right, so there's our term. And we draw our graph, right, meeting that. So our graph looks something like that. Now, what's the domain? My domain is all numbers except for this vertical asymptote. So domain is everything except negative 1. And the range, we can see it's going to go from negative infinity up to positive 1, then again from 1 to infinity. Now, the graph of 1 over x squared looks like this. As I plug in values that are close to 1, just like the graph of 1 over x, it gets really big values. But this time, since I'm squaring, both sides are positive. So I'm going to go out towards 0 on both ends, and I'm going to go up towards positive infinity at 0. My domain is everything but 0. My range is only the positives. So if I look at this, that plus 1 is inside the function. So that is a horizontal shift. So this is going to be left 1 unit. So I'm going to take my graph, and instead of having the vertical asymptote at y, it's going to be over here at negative 1. This is a stretch by 2. And so now I didn't move I didn't move up or down, so I'm not changing the horizontal asymptote. So we're going to redraw that figure, stretched by 2. And again, if I want to know this point, I can again set it equal to 0. And of course, I wasn't thinking when I just said that. That would give me my x-intercept, and that means, we never, right, this equation's not solvable. So we never hit the x-intercept, right? But my y-intercept, I'm setting the x to 0 to find this point right here. So I would go y equals 2 over 0 plus 1 squared. That's at 2. So 1, 2 is where we have that intercept. What's our domain? All numbers except negative 1. And what's our range? All the positives. Okay, let's look at this one. We are shifted left 1 and down 1. All right, so if I go left 1, down 1, I'm doing my vertical asymptote here and the horizontal asymptote here, and redrawing my figure through that. Now, by the way, where is my y-intercept? Plug in the 0, and I get 1. So 1 over 1 minus 1 is at 0. So I'm going to pass through the 0, 0. But otherwise, it looks just like the figure. And by the way, if I wanted this x-intercept, I could set the y to 0 and solve the equation. All right, now, the domain is everything but negative 1. And my range is negative 1 to infinity. Now, this graph is given to us. Where are the vertical asymptotes? Here and here. Now, the vertical asymptotes are vertical lines. So I'm looking for the equation of these two vertical lines. It's at x equals negative 2 and x equals positive 2. Now, where's the horizontal asymptote? That's this horizontal line. So I give it as a y equals 2. How about x and y intercepts? Well, we pass right here, but that's our only x or y intercept, right? So 0, 0. Now what happens as x approaches 2? Well, here's 2. From the right, we're going up to positive infinity. From the left, we're going down to negative infinity. Whoops. Go backwards a little bit. So that's the way we write that. As x approaches 2 from the right, we go to positive. From the left, negative. So we can say the absolute value approaches infinity as x approaches 2. What happens as x approaches infinity? Okay, infinity is out this way. Look at what we're getting closer and closer to, the y equals 2 value. So as x approaches infinity, these level off at y equals 2.